and go this one full mode. All right. So hopefully this one is giving you a full view. Okay. So this one is centered around 3D interactions. Okay, so see now it's timely that we talk about the active interactions. So I'll give you a bit of lecture on this, what is considered this in this space. Okay, you are familiar with some of it already during your tutorial. Okay, so this one is a compelling user experience diagram that we built before. So this one is actually start from the bottom. Okay, so you have a components here that you have a different component like display, tracking. Okay, so this one is really a fundamental. You think about it's a piece of electronics and algorithms that sit on enabling component. Okay, and to build a compelling user experience, you do need to have a tool that allow you to make use of those display or make use of those camera and tracking. And that's the tool that we've been using is the Unity Vuforia. Some you might do some AR Core or those sort of type of things that kind of sit inside that space. And applications that's what you are doing in the assignment, in most of the assignment, in the rest of the assignments of these units, which has interactions sit in that space. Okay, so that means application here really about using those two, about Unity, and try to access to those hardware, including your built-in webcams, and try to create interaction that meaningful. And ultimately, what you're hoping is a really top of the pyramid there. It's an experience. It's trying to create those experience. So remember, the user-centric design is really designed to get the right technology to create the right experience that you target for the application, the context of application you select for, which is the different scenario, the 3 scenario that I provide in each of the assignment sheet for this assignment. So that is what ultimately what aiming for you to write. So now you are working a little bit backward here. What interactions are more applicable to create those experience? Sorry, my annotations is start. So hopefully you get a sense of that. So definitions. So the 3D interactions here is how people task or carry out in 3D space. So that's really simple and straightforward. Okay, how would you move in 3D space? Okay, so some of these areas called 3D user interface. Okay, so this one is sometimes people call in short the 3D UIs. Okay, so this is a user interface that involve 3D interaction. Okay, so interactions, and also now once you have that, the last step here is 3D interaction techniques. What exact technique do you use to create a user interface? So hopefully this makes sense. So start with the 3D interaction general definitions and then go to what is the interface, the user interface you're looking for to create, and then the specific techniques. Okay. So for interaction tasks, for 2D that we're familiar with in the PC, so that's a GUI. So that's been around for 40 years. So Windows, icon, menus, pointers that we're familiar with now. And we're changing a little bit here, going a touch base, but it's still pretty much the same thing, window icon menus, okay? And then you have 3D tasks in VR, which is coming online in the last 2 decades or so. There's a navigation, there was selection, there manipulation, which we'll talk about today. And then we have AR, combination of these 2D and 3D tasks, okay, which is going to be interesting as well. So try to look for those. So AR is somewhat building on based on existing 2D and 3D tasks. Okay. Reference at the below is also useful to have a read. Okay. So for this interaction interface design path, it's usually start with a proof of concept, like what you do for your assignment here. You create something, a proof of concept there. So then you are generating what we call adoption of technique from the interface metaphor. So that's what usually what AR is. I try to get, we use this one, we use scanning, we use 3D wave finding, so things like that actually borrow from existing other technology. I'll be more mature. If you get certain technology more mature, then you get to the third step, the development of new interface metaphor. So that is what VR is sitting at the moment. Okay, so it's quite mature in the area, so you kind of know what interaction will look like in this space. Okay, so you sort of have customization as much more than what you have for AR. Okay, so you will know for the rest of the lecture here, we divide into two parts, in VR and AR. AR is a bit more boring. Other people interaction metaphor techniques to use, but by itself is still moving a bit. For VR, it's more mature. You would see from the slide there. And then if you get further down the road, just like the current the window icons interaction, the 2D GUI that we're using here, graphical user interface. So you will get a more formal deliverable model for predicting, okay, and modeling user action. What I talk about in the lecture in the subsequent weeks about evaluations and theories and something like that that are around this modeling components, so give you the idea what interface eventually get there. Okay. Having said that, it doesn't mean that interaction here will always start from a concept and all the way finalizing into the theoretical model. Because some interface came and go. They're not mature enough. They're not being adopted, so they're being not using it. People not using it. Sorry, I forgot to turn off the narration timing. I keep moving by itself. So VR interaction here. Okay, so this one 3D interaction in VR. Okay, so this one is object interaction. You have navigation. You have system control, which is system control, or more or less you using the object interaction, combining techniques and leading to some of that. So object interaction. So there was two very main things that people use is a selection. Okay, you inside VR, you're selecting, you click on something. Okay, so you select more virtual object in VR to create interaction. Okay, and then you can have an option to do manipulation, so modifying, changing the state of the object. Okay, this could be you clicking a cube, a 3D object, and then you try to orient it, rotate them, move them from one location, and then go to the other one, position and scale and color. Okay, or changing color. So some of these is very much possible for your assignment too. Okay, that you're doing now. So the common selection techniques in VR is quite intuitive. Okay, so you have a virtual hand, you have a ray casting. Okay, so the virtual hands is like this. Okay, you've been to the practical, you will get to see your hands inside a 3D environment. This is one of our VR application project that we did for forestry project. I'll talk about that in the subsequent slide, lecture. And you can see here how the hands move, how everything's mimicking the way you touch your controller or not touching your controller. And you can see here, they not recognize your thumb on the image on the top left here. They just recognize that you're not touching the joystick. So therefore interpret as those gesture. It's good enough. This is what Oculus did well for their interaction with your controller. Okay. And you can use that to touch on that object. When you're touching, that means that you just simply touch the virtual object that in front of you in 3D. Okay. So the virtual hand object is quite intuitive, so one-to-one scale between physical hands and representative of virtual hand. Remember, you are not actually see a virtual. You will get the in VR now. The standard is that you see a virtual hand and you feel like that virtual hand are representing your hand and where your hand is in space. So you will see like, oh, that's almost like you see through your goggle to see your hands, but it's instead of real hand, you see a virtual hand, but it's in the same location. Okay. So touching virtual object with virtual hands, so that's become a kind of key components and beauty of it. Okay, but it does come with limited by the reach. So both, if you have an object far away, you cannot really kind of touch them or reach them. So you either have to go to that place and select them. Okay, so that is come with those techniques. Okay, so that's why another technique for selection is called ray casting. Okay, so this think about it as like a laser pointer. Okay, so this is a metaphor is the way that you use it, laser pointer. So you're here, but you can point where your object is, things. So this usually attached to your hand control, VR hand controller. Okay. It's determine the 3D location of ray surface. So the ray will move from where it originated from the tip point of your controller, hand controller, and point to the surface wherever it intersect inside the 3D environment. Okay. And generate a visual feedback that that's where it's attracting. And then you have, but sometimes can be difficult to manipulate, because especially as the ray get longer, it's very hard to navigate it, to maneuver. Just think about it. You have a big long stick pole, and then you try to navigate to hit a point in 3D, which is maybe 10 meters away from you. So it's very hard to move your hands to kind of control the laser from the end point. Okay. So there's a limitation to that, but it's a very, for the simple animation, it's quite good. Okay, so this is generally what ray casting to look like. This one is come out from your hands, your controller. Okay, the image on the right show our application in the forestry that we use. Basically, we intersect with the floor and generate, okay, that's where we want to go. That's where the floor we want to interact. Or we can point to the tree, we collect the tree. The tree here is collected by LiDAR, floating on the UAV platform, scan the forest, that part of the project at the HitLab. And you can get the sense of this one. So you have a hand directing and you have ray casting. So those are kind of common themes that you can use. But in terms of manipulation, so in this case, it's a manipulation in VR. Okay, so you have a manipulation is oftentimes easy to do in direct hand, and this seems to be the most common way. Okay, so like this is from Oculus Quest. Okay, you can see your virtual hands. You can see grab the Coupé. Okay, you can see her move around. Okay, that's why the practical sessions is allow you to kind of play, not play with this particular demo, but to play with how you get used to the hands. Okay, and with the reference that Ron pointed out on Milo tutorial, you will get to see that actually you can access the hand location and click. So this become manipulation of it become more natural. Remember, this is done to the controller, the hand controller. Okay, this has been quite useful, or people at least adopt to it and use for it. Okay. One thing the practical hasn't really played with is an experimental version. It's basically instead of hand controller. Oh, sorry. So, can you hear the sound? Can you hear the sound? Let me check the feedback first. I just want to make sure the sound can be here. No, you cannot hear the sound. Okay, let me just a second there. But anyhow, the sound is not that important. Okay, it's for this one. Oh, okay, so someone can hear the sound, speaker volume. So my audio still works, but I'm not sure. Yeah, okay. So, but anyhow, the recording, I'm not sure what the recording will record, but it's the sound is not that important in this space. Okay, so let me try to see this back on. All right. So this is what experimental versions look like. Okay. So now hand controller now Oculus is launching this as an experimental version. So we didn't get a chance to look at this much in the practical session, but essentially it's already working. If you drop your hand, put your hand controller, they will recognize where your hand is, and has a 3D version of your hands now. And this become a common standard for a lot of VR and AR device. With HoloLens 2 is the same. So this is Oculus Quest that we play with in the practical session last week. And if you show us, you can develop your assignment 2 or 3 into this headset. All right, so hopefully that gives you a direct hand manipulation with hand tracking. Okay, so for navigation, so we talked about selections then and manipulation before, and then now it's navigation in VR. So there's a natural movements, okay, how you move inside the VR environments, and there's a second method which is called teleportation. Okay, so this one is basically natural movements. Okay, it's this one of our doing one of our testing in VR with our VR application there in Forest. So they go in there working on their task. Okay, so so in this case, that's what most practical students in the session last week will get a chance to look at. It's not the same thing as you move your mouse and keyboard to navigate your first person view. So this one is actually you can bend your knee, you can feel, you can walk, things like that. So it's quite a bit of useful to experience that. Okay. So there's sometimes there are tether systems in the most high-end that require high-end computer to run, like Oculus Rift S or HTC Vive. But the Quest that we use as our main headset is actually untethered. Okay, so that one is running on Snapdragons and those Qualcomm chip for mobile phone that used to run high-end phone. So essentially dropping an SDK into Android. Okay. So that one it actually has no movement, just like what the video showed before. Teleportation here, you're familiar with this one. So use a controller, select location, and before they move. So depend. This one look like a fishing rod. Okay, so you go and it's always pick the ground. Okay, or sometimes it's just simply as you point to the ground. Okay. However, this can be disconnecting if you do it very quickly. So it could be a motion that you're kind of disconnected from environment. Your scene will completely change, just like you're flashing in front of you. Okay, and if you do it very heavily, and if the scene is not static like this in the room in a static house, you might get a bit of sickness as well if the whole scene is moving while you're teleporting, and so therefore you lose a sense of directions and where you are. Yeah, that could be problematic. This one is a bit research work. Okay, this is a redirected walking. Okay, so this one is actually, since you still have limitation in physical space, whether you tether or untether for the VR headset. So this is what is playing rules, playing a trick on your vision system. It creates an illusion of walking in a straight line. Okay. So essentially here, you thought you are walking straight, but in reality, you are actually slowly rotating. Okay, so some example for that. Okay, so you can see here, this one look like he thinking he walking straight, but he actually walking in circle. This one has a sound as well, but it's not really relevant to the content. You don't have to hear that. Obviously, this is having effects when you actually need to have a physical walking interaction, but you don't really have the physical space for that. And you can see the view inside here. People think they're walking straight. So this, if you're interested, you can look at the paper. Okay, so the paper they published. So essentially here they manipulate the way the viewpoint that you see gradually. Okay, this one is more mechanical movements in terms of navigation. So on the left here is you can go to the website, which basically is Omni treadmill. Both of them look like that. So this one is actually you are wearing a specialized shoe that grab on this multi treadmill, and the headset is already tracking in 3 to 6 degrees of freedom. But this one is different. The one on the right, that one virtual sphere. Okay, that one is like a human hamster. So one of these hatch can open from outside, from yeah, outside and inside out, open, and you climb inside, and you actually sitting there and walking. Okay, walking in there, so you get unlimited there with the current HMD, the VR headset with Untethered one. This will be very handy. Okay. However, this will require a lot of physical space. Both of these platforms doesn't require you to do too much. They have this lower braid view at the bottom. So this one is physically moving. Okay, both of these has a bit of difficulty if you not have a good knee, because your inertial movement is there. So the problem with both is commonly when you try to change your direction, like you're going straight, it's okay, and wait until stop, and then rotate it like you go into intersection, it's okay. The problem is that when you actually walk and you look around to 45 degree and you just want to turn there, while you still have inertia of your body and your platform moving forward, that's require you to really use extra power to punch to step on the platform on this steering wheel, and also your platform here to change direction, and that sometimes can be bad for I mean, it's kind of physically demanding. Yeah, so there's a catch on that part. Okay, but it's a very lovely if you have one of those. I mean, the one on the left is relatively newer. Okay, all right, so maybe what I do here, stop here for a second here for 5 minutes. Okay, for everyone get stretched leg and be back for this